Okay, so again, two large rectangular aluminum plates of area 150 centimeters square face each other with a separation of 3 millimeters between them. They have equal charges, and the charges on the plate face each other. Find the flux through a circle of radius 3 centimeters. Okay, so here's a side view of the plates. Okay, this drawing, of course, is not to scale. This separation is 3 millimeters. And this area is 150 centimeters square. Okay. And what they're saying is the charges face each other. So if you put any charges on these two plates, they will collect here. And they collect like so, because that way the electric field inside here will be 0 and the electric field inside here will be 0. Okay? And you will learn in a couple of chapters. So for instance, here's a battery, here's a switch, here's a parallel plate capacitor, and when you close the switch, negative charges will collect here and positive charges will collect here. And what you have done by doing this, you have stored energy from here to there. Okay, you've transferred energy from here to there. And in this capacitor, here's how the charges collect. The charges collect on the inner surfaces. Okay. All right. Anyway, that's all that is. Okay. So sigma, the surface charge density, is given by the charge divided by the area, and on each plate, on this plate you have positive charge density, and this plate the charge density is negative, but sigma, the magnitude of sigma will be the same. Okay, and sigma is 20 microcoulombs divided by area of the face 150 centimeters square, and we'll convert that to 20 microcoulombs. Well, actually, yeah, hang on. Yeah, 20 into 10 minus 6 coulombs, and 150 centimeters square. 1 centimeter square is 10 minus 4 meters square. Okay. So what you get is 10 minus 2 on the top, so 0.2 divided by 150 coulomb per meter square, and that is equal to, all right, can I borrow a calculator again? What? Oh. Okay, so that's the surface charge density. All right, now, so here's what happens. Okay, so we have found the surface charge density. I'll do the diagram again here. And this is the positive charges. And I will use for the negative charges. Okay, so there's sigma, and there's this positive charge creates an, okay, inside the electric field is 0, so this is sigma by epsilon naught, and the negative charge also creates an electric field like that, which is sigma by epsilon naught. So the net electric field between the plates This is positive. Okay, so the net electric field between the plates is the electric field due to the positive charges plus the electric field due to the negative charges. And that's equal to 2 sigma epsilon. Okay. And what is it that we're trying to find? The charges on the plates face each other. Find the flux through a circle of radius. Okay. Now we want to find the flux. So we have found the electric field, and now we want to find the flux through there. So the flux through that is given by E net times area, because the electric field is perpendicular to the area and it's equal to that, and it's through a circle of radius 3 centimeters. Okay, so net times pi r squared. Okay, 2 sigma epsilon naught times pi r squared. So that's the flux through that. Okay, that's the number of lines threading this area. Again, that area is going to be, okay, there. So now we can put in the numbers. Okay, let me all right, so the flux is 2 pi epsilon naught is 8.85 into 10 minus. Can somebody check on this? The value for epsilon naught, and the units are no, epsilon naught is that, something like that. It's either 10 minus 12 or 10 minus 11. Mu is sigma is
You have the negative 12 there, so we need to 12 divided by 10 to the negative 12.
is this epsilon naught? Okay. Yep. Okay. So sigma is 1.33 into 10 minus 3 coulomb meter square, and then R was 3 centimeters square. Okay, so that's the flux, and the units for flux are units for electric field, which is Newton per coulomb times meter square. Okay. So anyway, this will work out to Newton per coulomb meter square. Okay, and let's take care of powers of 10. This is 10 minus 12. That's 10 minus 7. So you get to 10 plus 10 to the power plus 5 there. And then 2 pi into 1.33 into 9 divided by 8.85. Okay, so what does this work out to? and it's an electric flux. Okay, so roughly 1,000,000 units. All right, any questions on that before we close it?